Okay. So hi and welcome to my talk. It's about a small side project that I worked on, but I had a lot of fun doing it. And I think it's a very simple application of GNU Radio and SDR in general. And it's something very accessible. I did it with hardware for 35 euros. So maybe it gives you an idea of what you can look at and what's out there where you can kind of start playing with software-defined radio. So a bit about me. I'm Bastian, and I work a lot with software-defined radio, a bit at university, where I mainly work on Wi-Fi stuff, but also on sensor networking stuff, when we have a project where we actually put sensor modes on beds, so that was fun. And yeah, in my free time, I play around with different technologies, a bit with RDS, and try to receive what's out there. Okay, so these days, a lot of people are actually talking about smart cities, smart power grids, smart lights, smart everything. And smart often means networked, embedded systems. Network often means wireless. And yeah, but actually today I thought let's do the absolute opposite. Let's look at the absolute dumbest thing you could ever do. And in fact, when we in university have the course on embedded system, the kind of hello world application is always let's turn an LED on and off. And basically that's what I want to look at today. So let's turn some LEDs on and off. So in Germany we have some wireless traffic lights. There was a post on Hacker Day about what I am just showing, and then I read the comments and there was a discussion like, what the hell is he talking about? And then somebody explained that they seemingly have these wireless traffic lights in Europe, so I don't know if they just are not there in the US or whatever, but yeah. So it's about mobile traffic lights. And I just wanted to give a very brief shout out to my friends from Internetwache, because they just by chance found the same traffic lights in the GSM network. So they're usually scanning around in the internet and found that these wireless traffic lights actually have a GSM uplink. So for monitoring and configuration and stuff like that, they are actually online, so they were able to log in and do some stuff. So this was covered in the news last year. And just very recently, Mike Osman and Dominic Spill, they triggered some traffic lights with infrared. So today we want to look at this big antenna, and as you might guess, that doesn't look like GSM. So for the GSM uplink, they maybe didn't put this on the traffic light. So yeah, I was looking into this, and one friend of mine said whenever he's close to these traffic lights, his DAB, his digital audio radio, just stops working. So I thought, okay, yeah, let's look around in that area. And actually, that's a band which is kind of to regional allocated. So it's kind of land mobile radio. I'm not sure how the translation is in German. It's Betriebsfunk, and usually you have some FM modulations there. So I used the RTL SDR dongle that we've already seen today a lot, and I think all guys know it, and just started GQRX, and indeed there was a very strong signal when I was close to the traffic light. Okay, and usually on these bands they are FM modulated, and just tried it, and there were some, the signals look good which came out of there. And my normal workflow when doing these things is there's now really some really great tooling. So we have GQRX, where you have seen where I could easily see the signal and filter the signal. And then I just did some recording to a WAV file and loaded the WAV file in Spectrum. I will in a minute show you the tool. And Spectrum is really nice if you just want to get the signal parameters, see how it is modulated, the bits per second and stuff like that. And then after I know the signal parameters, I just do some simple decoding in GNU Radio. So let's first look at in Spectrum. So this is how the WAV file loaded in Spectrum looks like. If there's no transmission with FM, then we have just some noise here. And then here you can see the traffic lights. So there are always slots of 1 second. And in between we have 6 transmissions. So the fact that they look a bit different basically tells you that there seems to be a different SNR. So these are actually one traffic light and one is the other traffic light. So they are not sending this, just not one sending and the other is only receiving, but they are sending back and forth. So to assert that the other traffic light is still there. And they are sending different types of frames. So basically we have some ones that are slightly longer, which we will later see is the kind of master, which tells the other one what to show. And the other one is basically just reporting back. Or at some points, it's also telling the master that there is, for example, a car. Some mobile traffic lights that actually have cameras to detect if there's a car ahead, so they can maybe preempt the signal and give you priority and just not follow always a strict schedule. Okay, so this is a very, very rough, so zoomed out version of the signal. So let's have a closer look. So this is also in Spectrum still. It allows you to look at the signal and also have an overlay that helps you in finding the bit boundaries. And with this, it was pretty obvious if you zoomed in that there's some FSK modulation inside there, and the bit rate was 100 bit per second. So you always have, so this is always 1 bit, and it's altering between 1200 and 1800 hertz. So you either have a complete cycle or 1.5 cycle in there. So this was basically the most important thing about the signal. And with this, I kind of manually decoded the preamble. Maybe I think in Spectrum also has some possibility to decode the signal, but I just manually wrote down the preamble because this is then what I needed in GNU Radio. And so with all knowing this, I can basically come up with a simple GNU Radio flow graph to decode this thing. Actually, now I'm still claiming that, oh, and then it's so simple and I'm just doing that step, but I think that this is the step that might be the most challenging for several people. But the message is that maybe this is the most stupid way to decode the signal, but it's just what I kind of came up with. And basically here in the last step, it just looks for the preamble, and then I have one custom block, which is also just one line of code. It's just whenever it finds the preamble, it's just outputting, I guess, 200 bits or something like that. So I end up with a lot of bits on my console, and I've just piped it into a file and wanted to have a look at how to decode, how to make some sense out of the bits. And I played a bit around in Vim, and because I like the workflow so much, I thought I'd make a very, very brief video. So actually this is 2.5 minutes of reverse engineering, and it's now twice the speed. So you had 2 frame formats. Okay, now it's just selected 1. If you scroll up and down, you see very, very easily the boundaries where there's some information in there. And basically what's in the frame is, so now we get rid of that. If we now scroll up and down, we already see some patterns in there, and then I just split it. And from this, it has some kind of timer, or it seems to be a timer that's counting upwards whenever a new complete cycle begins. And then here, I just found something which changes from time to time, and this turned out to be actually the phases of the traffic light. And in the beginning, I had some repeating pattern, so I thought, okay, this seems to be the same thing. If both show the same, hopefully it's 2 times red. And then started from there to make some sense out of it. So with this, then I had at least an idea of how the signal could look, and I created some easy interface so for the web browser. I mean, GNU Radio, we already had it in the file. I have some very shitty web GUI, which was reading the file and then just showing the actual state of the traffic light then in a web browser. And then, of course, I had to go outside, and hope you didn't drink too much beer because it's really shaky here. It was really cold. So I had 2 different types of traffic light. This one was directly in front of our university, and so this was really convenient to work, except that it was in the night and pretty cold. And then with another one where I also have a video on my website, so if you want to give it a try. But here it was just with the light, it's just much easier to see that it's kind of following the traffic light. Okay, so that was I actually can receive it, and whenever, actually I was pretty happy with that and already kind of good enough, but whenever I showed it to someone, the obvious question was, yeah. and I thought, okay, at least I should kind of include it in the talk a bit and say a word about it. Okay, I thought about, okay, how can I transmit? I have one of those, but I'm very sure that it doesn't allow me to transmit out of the amateur radio bands. So maybe it can receive there, but transmitting is limited. I looked on eBay. You can, of course, buy lots of these land mobile radios, or however they are actually called. but they are a bit expensive, or a bit over 100 euros usually. And then I remember that at some point I bought this incredibly cheap, shitty device from China and never actually used it. And it turns out with this 25 euro, it's kind of very nice because it's cheap and it's portable. And even in the link on Amazon, it was 172 megahertz. Yeah, if you play around with it, that yeah, turns out that that can actually work, or at least I wanted to give it a try. Good. What can you do? There's the obvious way, like going beside the traffic light and just screaming in the radio, and then you're basically jamming, disrupting the communication. But it's pretty boring because it's always possible. But when I had that on my blog, there was immediately somebody who wrote me that he tried that, obviously, or for whatever reason he knew that when you just jam it, it's just flashing orange, which makes a lot of sense because this is the kind of fallback solution. What else can you do? So the actual question is, like, could you spoof transmission? Means like you could generate the signals yourself so that the traffic light would accept it, so that you can actually trigger the traffic light. This is what yeah, most people seem to be interested in. But as I said, most of them have cameras and you should not mess around. And also with the GSM uplink, they will they know probably if you're doing some shitty stuff with it. So I thought, but still I wanted to see if there is at least some, I can come up with a proof of concept that maybe you could further investigate it. So, okay, I did another GUI, but this time obviously I wanted to trigger it. Then I again had a GNU radio flow graph where I wanted to, when I kind of was generating the signal that I just showed you. And this time it was just really plain GNU radio blocks. So there's nothing what I had to code. It was basically, I have two signal sources which produce the 1200 hertz signal and the 1800 hertz signal. And then I have some logic with the bits which is kind of be turning one on and off. That's in a high level overview of the thing. So what this then does is, this time it's not connected to SDR or software-defined radio stuff, but this time it's just outputting the signal into an audio sync. And then it was kind of a no risk, no fun. I could just connected it directly, the line out of my PC, to the radio. Actually, when you look online, they don't recommend doing that. So I used a USB audio card because I was hoping maybe then just the USB version is broken and not directly my PC. But at least for me it worked. Actually, you should decouple them, I guess, but I'm not really good in circuits and stuff like that. Okay, so the thing is, if you enable Vox, so I guess all the amateur radios like know it, is you can switch between push to talk and that the radio just turns on whenever there is some signal. So I enabled Vox on the radio, connected it to the line in of the microphone, and yeah, there you basically then have your transceiver. And I just have a very brief demo of the setup on my desk at university. So you see I have another GUI here. Then there's GNU radio stuff going on, and it's then connected to the handheld radio here. And on the other side, there's the other GNU radio receiver that I just showed you that was working with the normal traffic light. So it's the same frequency, the very same thing, everything's the same. So I was really generating a signal just as the traffic light. So yeah, so much for the you can also maybe transmit, at least in general. So yeah, so that's it from my side. I hope yeah, you find it a bit funny application, and also am now motivated to play a bit around with this cheap technologies that are out there. Okay, so, thanks. Is it half?
Sorry?
Was
yeah, it's half. Yeah,
oh, I'm sorry. Actually, I thought it's way too much content, so now I was rushing around through the slides. I'm sorry. Yeah, so if you have any questions.
Do you know if anyone would try it?
No.
As an kind of question from the internet. Did you try?
Asking.
Ask if he knows that anyone tried.
Gefährlicher Eingriff in den Straßenverkehr.
Yeah. So usually exactly. So that's usually what happens. That if somebody does it, then hey, done that 5 years ago or something like that. But actually, seriously, no. So nobody wrote me. So I wouldn't know if anybody. I also tried different. I got emails from other guys who were looking into that, but none of them were actually transmitting something. Yeah.
What about slide 22? You said that the light is just outside the university.
What? So.
You're transmitting, so.
Yeah, this is the anechoic chamber of our university. What? No, that's.
I'm using another frequency. There was another light before me.
All this has metallized windows where nothing gets out.
It's a Faraday cage.
Exactly. Yeah. Yes. So there seems to be the configuration always seems to be that the one is kind of the main the master of the communication, yeah, and the others are just kind of reporting back periodically so that the master actually knows that what he was transmitting actually was received. So not that the master turns green and the other doesn't. Yeah, and also on this frequency, you don't have to space them that close because you're actually on 170 megahertz, you get some range. Yeah. Yeah.
So you mentioned that new radio is usually the tricky part to get the reverse engineering going. So I was just curious to know if you played with wave convergence. This is like this new tool that was published at SHMUCON, so it seems to be one tool that makes all the work for you, that figures out the timbre and everything.
So I don't know that particular tool, but
The question each time, please.
so if I already tried, if I tried another tool that was recently released at SHMUCON, which is called Airwave, I guess, or how did you say?
The one I mentioned is wave converter.
Wave converter, sorry. Yeah, I don't know that particular tool, but today in the morning we had a panel where we said about like it's sometimes really hard to get started with GNU Radio, and then when I had another look at my slides, then I knew that okay, now I say I have all signal parameters, I know the preamble, and now I just have to build the GNU Radio receiver. And then this is when I realized that most likely this will be the tricky part for most of the people, so that they really come from this now, because loading it in a Spectrum is pretty straightforward, I would say, and then also having some high-level overview, but then from that to the transmitter, that might be the part where people draw off, yeah. But maybe this is something where you maybe could come up with some default standard solution where you maybe can just plug in different values, like one for on-off keying, one generic one for FM, and stuff like that. There are some out there, but they are kind of distributed. So
basically, what wave converters does is basically you just feed the IQ data and it figures out everything for you.
So you don't even need the parameters. Yeah. Okay.
Okay, this is the zeros and one for you. Just
Okay. So these wave converters, yeah, I should have a look at it and see. Yeah. Yes. No, because I think it's because so it is really a kind of really straightforward, and I think it also doesn't make a lot of sense. I had a look at two traffic lights. They all are slightly different. Also, they might have different configurations. So most likely that wouldn't work out of the box either way. So you have to do some slight adaptations. But the main point is actually that this is something very straightforward. You can just have a look at it, and also it shouldn't be just I just download, compile, and run a thing, I guess. Yeah. Yeah.
Just looked it up. You can just rent a set of these traffic lights if you want to.
Yeah, the ones at university they actually rent, and it looks like then the company is doing the monitoring of the traffic lights, and also most likely the configuration stuff, everything remotely, and you just put them there. Yeah.
Have you found any other examples of these smart devices that you could reverse engineer in smart cities kind of scenario?
Yeah, so when I look back, actually, then mainly I always had to do something with traffic. Even I actually didn't think about it. So what my other projects were, I received telemetry from buses. So I had a open street map where you could see the buses in Paderborn driving around. And I had a presentation 2 years ago with RDS TMC. So this is the digital subcarrier on FM broadcast data. So there's also some traffic information modulated on there. So your usual GPS device gets it from the FM broadcast stations. And also I have a project which is available is decoding my car key fob, for example. Then you get the 64-bit rolling code out of it, and yeah, stuff like that. So there's tons of this very, very low-hanging fruits out there where you can have some fun playing around with. Yeah.
You had tips about the first step. How do you find the signal along the spectrum?
Yeah, so usually when you are close to it, then it should be very, very dominant and clear that it's there. I mean, if you have absolutely no idea about the band, so with this I really had an idea, and I also, if I wouldn't have known that it kind of interferes with the DAB audio stuff, then I would have started there. So if you have a rough idea about the frequency allocation, there are some spots to look. But yeah, in general, if you just use GQRX and scroll through the band, I guess you should see it very dominant. For example, with the buses also, I had no clue where they are, but when one drove by me very close, it was just bam, so you couldn't miss it.
In this case, the antenna length would also give you a hit.
Yeah, but for this small distances, nobody don't even have to pull it out.
No, I mean the antenna on top of the traffic light.
Ah, yeah. So this is a lambda half dipole. Yeah. So what was it? 2 meter band, 1 meter antenna? I don't know. Yeah. Okay. Thanks.